Hello and welcome to Scratch Lesson 7 Part 2. In this lesson we're going to learn a little bit more about lists, and it's probably an intermediate type of lesson where we're going to use two lists to update the position or the coordinates of several sprites to make a tail that follows the head around the screen. So just to start off and make it a little bit easier and this video not so long, I've already created some segments and some sprites for us to use. We have a head segment, which is the one that will move around the screen, and we also have segments of the tail that I've made using the costume editor, and I've made a very simple looking tail which is just a square, and these squares have slightly different colors, so the tail looks like it's going to kind of fade off as time goes by. So this list tutorial is going to show us how we can update the positions of each segment of our tail to follow the head as the head moves around the screen. This segment, just to be quick about this, was made in the costume editor. I made just a little square, and if I zoom in to maximum magnification, you can see I simply used the rectangle shape maker and pulled it across 2 squares by 2 squares wide, and I labeled it segment 4 or segment 3, 2, or 1 depending on where I want it to be in the tail. So I've already created that, and let's go back and do the programming now. And in the head, I'm going to do the majority of the programming, which will get the head to move around the screen. So let's start with that. We're going to go to Events, and we're going to create an event when the program starts to forever follow the pointer around the screen. So if I go to motion blocks, I can see I can have a point in the direction or point towards. Well, I want it to point towards my mouse pointer and to move towards it as I move my pointer around the screen. So I'll have it move 10 steps. That's fine to start with. And I want there to be a delay. I want this delay to slow down the speed of the head so it doesn't go right to the mouse pointer immediately. I'll make a variable for this particular sprite. Call it I don't know, step speed. And click OK. Actually, that'll be the speed that it actually steps at. So I'll put that into here, but I'm also going to make a delay. I'm going to have it wait. Let's call it step delay. And again, that'll be specific to this particular sprite, so I'm going to make a new variable for this sprite only. Call it step delay. Okay, and put that in here for this. So when I click the start arrow, the head of my little animal that I'm making should start to move towards wherever my pointer is on the screen. And let's give that a try. Actually, before we do that, let's set the values up. So we'll say when this is clicked, let's immediately set the values of these two variables I just made. Let's set the step delay to be, well, I don't know, 0.01 seconds. And let's set the step delay or the step speed to be 10. I can now adjust these values later. And it may not seem like I'm gaining much by doing this, but if I were to make more sections of code that involved using the step speed and step delay, I can simply use the variables there and update them over here only once. So that's the advantage of initializing variables to start with in a program that are used in other blocks everywhere else in your program. So let me see, I made this steps 10. Let's try that. And there it is. There's my head chasing after the pointer of my that I've got moving around the screen. It's following it really nicely. It's locking on and it's moving in fast. So that looks pretty cool. Let's stop that. What I want to have happen is as the head moves around following me, I continually update the coordinates of the head, the X and Y positions of that head. And then I pass those on to the tail segments, and those tail segments will then move to those coordinate positions, and the tail will follow along the head in a very realistic manner, and it can snake around the screen if the head moves in that manner too. So that's the purpose, and we're going to use lists and to make that happen. So we'll make some lists right now, and these lists will actually be lists to contain the X and Y coordinates of the head's position, and you'll continually update them. Each sprite, though, must have its own unique x and y coordinate that is just behind the tail position that was in front of it, so that they won't overlap too much, and they'll move as a sequence. So we're going to, with that in mind, let's make a list, and let's call it x coordinates. Let's go underscore coordinates. And it's going to be for all sprites, because I want all sprites to be able to use the data in my x coordinate list. So click OK. And then I'll do this one more time, and I'll do it for y coordinates. And do it for all sprites as well. Oops, for all the sprites. Click OK. And that will be creating two arrays, as you can see them here, or lists as we call them in Scratch, that will hold the x and y coordinates of the head segment and all the other segments going through here. So therefore, to start things off, you want to set these list elements to 0. Good programming practice has you initialize lists to 0 or some start value, so that when your program runs, it knows what values it has in it. And in Scratch, if I fill a list with values, then close my program and reopen it, if I haven't explicitly deleted those values, they'll still be there. Now that can be very useful, or it can be a problem, but you have to know what you're doing. So let's start off by making these lists hold only 4 elements, and set those elements to 0, so I know every time I start my program, I've reset the data in these lists. And to do that, I'm just going to have it use some of these program blocks. Delete, I'll use it twice, and I'll delete all the elements in my x coordinates and all the elements in my y coordinates every time this program starts. Then I'm going to fill those elements with values of 0, just to make sure that they're properly initialized. And I'm only going to have 4 elements in this list, so I'm going to repeat this step 4 times, and I'm simply going to add 0 to my list elements. We'll see what happens when I run this. Add, there we go. Add 0. By the way, you can almost add anything to a list. You can add numbers, you can add letters, you can add objects to lists, which make them very powerful. I'm going to set my x coordinates to 0 and my y coordinates. So really I'm actually making 4 elements in my list, and I'm making them contain the number 0 to start with. So when I click this start, boom, you see them come in here. I've created 4 elements. They're all 0. Very good programming practice to make sure your lists or arrays are initialized and set to some starting value that you know they are when you begin your program, and it makes debugging much easier when that time comes. And you will for sure have to debug. Nobody writes a perfect program the first time around. So there they are, and what I'm going to have it do is then update the positions of this head. So let me just grab this head here, move it into the screen. This is segment 1, I'm moving in after him. Segment 2 is here, 3 and 4. So to give you a better idea of what I want to do is I want to take a snapshot of the position of the head, at least its x and y coordinates, so that I know exactly where it is. Then as it moves, I need to pass those coordinates that it had right here onto segment number 1, and segment number 1 has to move right to where the head was. And following along, segment 2 has to follow segment 3, segment 3 has to follow 2, and 4 has to follow 3. And it has to continually update like this all the time. But we have to be careful about this, because if I move the head, let's say I get these coordinates and I store them, then I move them to here, I also have to know the coordinates of all the other 4 tails so they can move up the line accordingly. And if I update this sprite or this segment's position to the head's position, I've immediately lost whatever information it had about its current position, and then I can't pass that on to the other segment that follows behind it. So really what I have to do is I have to take this segment, pass its values on to the 4th segment, pass this segment's values back onto this one, and this to this one, and then update the head's position to here and get a new value for my head. So to illustrate this better, let's go back to our lists and let's make it when we start our program that we start updating our lists. So I'm going to do this and say forever. We are going to replace, and the order has to be specific. We're going to start replacing segment 4, the very last segment in my tail, with whatever coordinate value is in segment 3. So I'll go replace item 4 coordinate, and let's start with the x values, with item 3 of my x values. So I've passed the coordinate position of my third segment onto the fourth segment, and I'm going to do the same thing with the second, or the second segment onto the third, or the third onto the, I'm losing track of my count here. This is fourth, third, second, first. So I'm going to now that I've passed the third segment's coordinates onto the fourth, I'm going to pass the second tail segment's coordinates onto the third, and then the first segment's coordinates onto the second. I have to do it in that order. I'm just going to do, whoop, that was a mistake. Let's try that again. So I'm replacing the fourth segment with a third of the, I'll just leave this y coordinates, duplicate this, make 4 sections to update the 4 different positions. So then I have to replace the third position with the second position with the first, then the first tail segment's position will then take on the head's current position. So I go down and I say the first position will now take on the actual position of the head, and these are y positions we're using here. Okay. Actually, I have to replace them with the, not the item, but just the y position, just like this. So the y position of the head goes to the first position, but it can't do that at the first step. So when I have this sprite here, I can't update this first segment first thing, because I will lose whatever data it had about its coordinates, so I won't be able to pass it on to the second segment of the tail, and then so on and so forth. I have to work from the back tail segment up so that I keep the appropriate x coordinates or y coordinates of each of these segments and only update them once I've passed on their value to the segment behind them. I'm going to duplicate this chunk of code, except I'm going to do this now with the x coordinates. So that's all I have to do is change these to x coordinates. And I'm going to, got to make sure I don't leave this y position here. This one is for the x coordinates, so I have to get the x position of the sprite's head. So now whenever the sprite moves, there's new coordinates for it. It passes on its old coordinates to each of these tail segments, but we pass them on from the fourth tail segment up to the first so that I don't lose the coordinates of the segment in front of it. That's an important step. If you try to do this 1 replace with 2 and then 2 with 3 and 3 with 4, I'll leave that to you as an exercise to try and see what happens, and you'll see that you'll lose the proper coordinates before you can update them, and this will not work properly. So just starting this off, I've got this moving around beautifully. Of course, as you can see, the list's elements are continually being updated, and they're being updated very quickly to follow or to get the coordinates of the particular sprite. Now what I want to do is have these segments follow. So really the next step here is to just do something reasonably simple. I'm going to have the segments, each segment will have its own set of code. So if I go to segment 1, I'm going to make when this program starts to forever move to position the coordinates of the x and y coordinate position 1. Okay, so I'm going to have it go to, or I'm going to set its position, set its x, and set its y to the first elements of my x and y coordinates, because that's where segment 1 of the tail has to be. So I'm just going to go back to my data and go item 1 of the x coordinates and item 1 of y coordinates. And what I didn't do though was set a delay to this. So we'll just leave it the way it is right now and see what happens. We might need to add a delay so it doesn't do this too quickly, but let's try it out. This same block of code will apply to the other segments of my tail, but I have to update them to the appropriate elements in my list. So I'm just going to duplicate this and pass it on to the other segments of the tail. Go into those segments and make sure that I've got the appropriate item of my x coordinates for the second sprite. So this is segment 2. It must have the second element in it. Segment 3 should have the third. Oh. And segment 4 should have the fourth. Okay, so let's just see what kind of crazy thing happened. There it goes. So already I have a tail following the head, and the head's moving around the screen. The only problem here is that these tail segments are updating so quickly they're on top of each other, it appears. So that's not really the motion I want. I'm going to make a delay for this, and I'll call it a list delay. So I'll go back to make a variable, and this is going to be for all sprites, and it's going to be the delay that I introduced to slow down the rate at which the list actually updates its values. So it's going to be all this for all sprites. I'll click OK, and I'm going to set my list delay to, I don't know, this is where you have to play with it a little bit. Let's set it to 0.01 again. So I've got the list delay of 0.01, the step speed is 10, and the speed at which I move my head around the screen's delay, or the delay between movements, is 0.01 as well. I don't expect that you'd be able to get these numbers right off the bat. You'd have to play with them, and perhaps my numbers need to be corrected too. So let's try this again. And as you can see, my list is still, oh, of course nothing's happened because I actually haven't implemented this list delay. I have to go back to my portions of code and put this list delay in there. Let's put the list delay in here so we can slow down the rate at which we are updating the elements of each of these lists, or arrays as you may wish to call them. And let's make this list delay now. So we'll update how quickly we're updating our list. We'll slow that down a hair, and we're also going to slow down the list delay is also going to be implemented in each of our segments to slow down how quickly they move. So let's go into here and let's go wait. Let's put it up here, and we're going to go list delay. And just to speed things up, I'm going to duplicate this code, drop it into all the other segments of the tail so that I don't have to keep rewriting it. I'm going to put it back where it belongs here, and then go into these segments and place them where they belong inside these forever statements. Okay, and let's run it. Okay, there you go. We now have the segments of the tail have stretched out behind the head, and they act very realistically. This looks like a little worm or snake going across the screen. They're updating to the positions of the tail segment in front of them, and they're doing exactly as we hoped they'd done. Now we can get this tail, we can do several other things. We can make this tail stretch out more by increasing our list delay. We can play with the different or the different values of our step speed and step delay to make this look more realistic. Of course, you can also choose different shapes for your particular tail to make it look more interesting. But the real purpose of this lesson was implementing lists in another manner that's a little bit more useful, or perhaps a little bit more indicative of what we can do with lists. And we can leave it more advanced topics for later, we can actually make a list that holds more than one coordinates. I could have made one list that had the x and y values in each element of my list. That would be a two-dimensional list. These, which is we'll leave for another lesson down the road. Anyway, I hope this made some sense to you, and I encourage you to try it in your code and work out any bugs that you might have for yourself. Thank you for listening, and stay tuned for the next lesson.